स्टार्ट हम कर लेते हैं ये last class में what we did was we learned you've already done this so we learned what thing we learned कि ठीक है भैया मैं पहले ही रिवाइज कर रहा हूँ So what we learned was that you had excess method, you had ionic precipitation, you had titration. These were methods for making salts or preparing salts. And just let me leave one message. I said so we did ionic precipitation, we did titration, and what I told you was that you've got 4 reactions which are used to make salts. One is an acid plus base reaction that produces salt plus water. You got an acid plus metal carbonate reaction that produces salt and water plus carbon dioxide. You have an acid plus metal reaction, and you had, if you want to make an ammonium salt that contains NH4 plus 1, you got an acid plus NH3 reaction that produces an ammonium salt. So titration was when you had soluble reactants and the salt that you're trying to produce is also that is also soluble. So we did titration, and sorry. So we did titration, and in titration we did a few questions in which what we did was that if you take any random salt, let me just take another one. Let me just extend this. So if we take some random salt, let's say that's barium nitrate. Now, if I want to make barium nitrate, that's the salt I'm trying to make. Now, barium is group 2, so barium is +2, NO3 is -1, and I want to make this salt. The first thing is I would have to come up with the reaction, and it's a soluble salt. How do I know it's a soluble salt? Because the reason it's a soluble salt is that it's got NO3 in it. Anything, if you look at the table, the solubility table, anything that contains NO3 -1, all nitrates compounds are soluble. So anything that has nitrate in it, that is considered to be soluble. So barium nitrate is soluble. So if I want to make barium nitrate, I would need an acid. So can anyone guess what acid would I use to make barium nitrate? And I've got 3-4 options. Whenever I want to make a salt, I've got these 4 reactions. I can react an acid with a base, acid with a metal carbonate, or acid with a metal. So I've got 3 options in which I can make the salt. So ये कोई बता दे कि what acid would you use to make barium nitrate? That's obviously going to be HNO3 because it's got NO3 in it. So the acid that I'm going to use over here, that's nitric acid, that's HNO3. And I've got 3 options now. Remember, with the acid, all of them are going to produce the same salt. So I'm going to write 3 reactions. And I can choose any one, pick and choose any one of them. So I've written this 3 times. And so the first one is I can use barium metal. If I use barium metal, that's a metal plus acid reaction. And it would produce hydrogen gas. So it's going to produce H2 gas. And there's going to be, to balance it, there's going to be 2 hydrogens. I could use a base as well. The base is a metal oxide or a hydroxide. So the metal hydroxide would be barium hydroxide. So I could use barium hydroxide. When I use a base plus acid reaction, it produces salt plus. It produces salt plus H2O. The third one is I could use a carbonate as well. So a metal carbonate could be used, and the metal carbonate in this case would be barium carbonate. So I could use barium carbonate, and this time it's going to produce a salt, a water molecule, and a carbon dioxide gas molecule as well. And every time you can balance the equation, it's going to be 2HNO3. And this one would be 2 as well. ठीक है, यहाँ तक clear है? So I figured out 3 reactions for making barium nitrate, and at the moment these are just 3 reactions. Clear, Zainab, Mariam, Aiden, is this clear?
आप दोबारा बता सकते हैं देखो।
नहीं, मैं तो वही कर रहा था कल वाला कि बैरियम नाइट्रेट बनानी है ना, तो एसिड कौन सा यूज करोगे? नाइट्रिक एसिड. And there's 3 ways in which you can make the salt. You could either use a metal, you could either use a base, or you could use a carbonate. ठीक है? Clear है?
Okay, sir.
So now you've got these 3 reactions, and the salt is soluble. अच्छा, acids वैसे ही सारे, all acids are solutions, they're all always soluble. So all acids are going to be soluble. I said, now what about barium? That's a metal, so that's a solid, and H2 is a gas. So when you try to make a soluble salt from an insoluble reactant, that is going to be excess method. So the first one is, the rule is, जो method आप use करोगे ना for preparing the experimental method, that's going to be excess method for the first one. ठीक है? Because whenever the rule is, वो हमने start में rules लिखे थे, कहाँ लिखे थे? यहाँ पे. The rule was, whenever there's an insoluble reactant and the salt that you're trying to make is a soluble salt, that's going to be excess method. Titration कब होगा? जब सारे soluble होंगे. The reactants are soluble and the salt that is being made, that's also soluble. Or if you're making insoluble salt, that's going to be ionic precipitation. At this point, we're not making that, so we can ignore that one. अच्छा, hydroxides का क्या होता है? Barium hydroxide, is it soluble or not? We can just have a look at the table. So if you look at barium hydroxides, तो वो लिखा हुआ है कि group 1 hydroxides and oxides are soluble, and those lower down in group 2, that also includes barium hydroxide, so that is soluble. So barium hydroxide, कहाँ गया हमारा barium hydroxide? That is soluble. ठीक है, this one. And the last one is carbonates are insoluble, so this one is a solid. Carbonates का भी उसमें लिखा हुआ है कि they are mostly insoluble except for group 1. This is not group 1. This one is a liquid and this one is a gas. Achha, so the last one is also excess method. So that is also excess method. The middle one is the one that is going to be titration. So the middle one is the one that's where titration would be used as a method for preparation. Is this clear, this thing? Clear here?
जी sir.
अच्छा, अब ये करना है कि what you have to do is you, I mean, we did last time, we learned titration. So I wanted to write the exam answer. How would you describe titration? So in titration, what you're going to do is, I'm just going to in key position switch kar dete hain. So bring this. ठीक है. अच्छा, so titration. All you have to do is you have to mix these 2 reactants together and you'll get your salt. इसको उठाओ और इसको उठाओ, दोनों को mix कर दो. लेकिन mix करना इतना आसान नहीं, because they're all soluble. So what I told you was that you're going to take a burette, fill the burette with any one of the reactants, and bottom के ऊपर there's going to be a flask, and that flask would contain the other reactant. So what you'll have is, okay, top center you'll add barium hydroxide, or bottom pe you will have nitric acid, or it could be the other way around. Or what you have to do is, what you have to do is कि इनको आप आहिस्ता आहिस्ता ऊपर से ना you'll add barium hydroxide drop by drop. Once you add it, the two react and they start producing the salt and water molecules. So there's going to be a reaction, and barium nitrate and water is going to be produced. So आपने करना क्या? What you have to do is you'll turn on the tap. You'll continue to pour in barium hydroxide ताकि वो जाके ना इसके साथ react करे. And at the end point, the last molecule of nitric acid would also get used up. वो भी इसमें convert हो जाएगा. So at this point, you should turn off the tap. ठीक है? So you should stop titration. When the last molecule of nitric acid reacts, you should stop adding barium hydroxide from the top. Because if you don't, तो barium hydroxide क्या हो जाएगा? Extra चला जाएगा. So there's going to be excess barium hydroxide. So you have to prevent adding, because you can't remove it. All of them are soluble, so they'll mix in with each other. So your salt is going to be contaminated. So you want your salt, you want to get rid of all the nitric acid, you want all of it to react. You don't want it to remain in the mixture because your salt would be contaminated by it. So you want to get rid of it completely. You want it to be completely gone, completely reacted. So the last molecule should also react. And at this point, you should stop the stopwatch. Extra barium hydroxide nahi dalna, because then that will contaminate the salt. So this is what you do. Or wo phir hum kaisa karte the कि what we did was that initially the solution is acidic because it's got an acid in it. Agar barium hydroxide excess pe chala gaya, that's a base, so the solution would become basic. So the point at which the solution switches from acidic to basic, that's the point where you should stop the stopwatch. If the solution is acidic, that means there is still nitric acid left. If the solution has turned basic, that means you've added extra barium hydroxide. So this is the exact middle way you should stop. ठीक है, ये सारा clear है? ये हमने कल भी किया था. Mariam, Zainab, is this clear? Aiden, is this clear?
Yes, sir.
And we had indicators to do this that would tell us the color changes. We learned those indicators as well. So just 1 second. So you had these indicators that would change color. Methyl orange would be having a different color in acidic, and basic color it would be yellow. So in this case, if the solution is acidic, it would be red in color. If its solution is basic, it's going to be yellow in color. So I'm going to write down the steps now. This is how you're going to answer this in your exam. So the steps are, okay, fill the burette. That's the first one. So it starts off with fill the burette with fill the burette with what did we fill it with? Barium hydroxide, aqueous. Bottom पे add a few drops. Sorry, not add, pipette. $25 cm cube of the other reagent, which is HNO3, into the conical flask. Now, once you do that, you're going to fill it into the conical flask. And once you do that, add a few drops of methyl orange indicator or any indicator. So I'll just write indicator in general. So it could be methyl orange or it could be phenolphthalein. So that's the first thing. Then you're going to start the titration by adding barium hydroxide from the top. Like you're going to start adding barium hydroxide from the top. So start titration. And add barium hydroxide from the top, from the burette. Drop by drop. Once that happens, you're going to stop when the color changes. So stop titration when color changes, and depending on the indicator, the color change would be different. Now, if you've stopped over here, then the solution will only contain barium nitrate and water. That's it. There's no other impurity that's going to be present if you stop over here at this point. So it's only going to contain barium nitrate and water molecules. And but it's going to be contaminated by one thing, and that is the indicator. So what you're going to do is you're going to remove the indicator. So to remove the indicator, what you're going to do is add charcoal. Charcoal is an absorbent material to remove indicator. So you're going to add that, and then you're going to do crystallization, because now you've got a solution that contains the salt plus water. So you have to get rid of the water, you have to remove the water, you have to evaporate the water. So you're going to explain crystallization right at the end. So वो फिर explain कर दो. Now, what is crystallization? Crystallization is you evaporate the solution till saturation point. Till the saturation point and cool gradually. And filter out the crystals that are formed. And right at the end, what you'll do is filter out the crystals formed, and right at the end, you're going to do dry the crystals between filter papers or in sunlight. Okay, so this is all that you have to write when you're explaining titration. Is this clear? You clear it? Yes or no? Mayim, Zainab? अच्छा अब so this is titration. ठीक है, remember you're going to make a soluble salt from an insoluble from a soluble reactant. So try and do the let's try and do another one. Okay, I'll just think of any soluble salt. And remember, you can't always use titration. वो depend करता है उसकी state के ऊपर. So I'll just do some of the random soluble salt. Let's go with sodium phosphate. Let's say बल्कि ammonium nitrate कर लेते हैं. Ammonium sulfate कर लेते हैं. Now ammonium sulfate is going to be ammonium is +1, SO4 is -2, so it's going to be NH4 twice and SO4. तो ये हम कर लेते हैं और इसको प्रोड्यूस करना है सॉल्ट को. अब इस सॉल्ट को प्रोड्यूस करने के लिए what you need is, now that's an ammonium salt. तो अमोनियम सॉल्ट के लिए कौन सा वो चारों में से कौन सी इक्वेशन यूज करनी है? What you're going to do is you're going to use किधर गई है? To make an ammonium salt, you would use an acid plus ammonia reaction. तो acid कोई जल्दी से बता दे कि what acid should I use to make this salt? I mean, it's going to be ammonia plus acid. So ammonia is NH3. Acid कौन सा? That is H2SO4. ठीक है. So that is H2SO4. अच्छा, तो ammonia plus acid. और इसको आप बैलेंस कर दो. Now all of them are soluble. ये टेबल के अंदर लिखा हुआ है कि कोई भी अमोनियम वाली चीज है ना, that is all soluble. Acid वैसे ही soluble होता है. And ammonia is also aqueous. Now it's going to be done exactly the same way. आपने क्या करना है? You're going to just copy the whole thing. नाम change करना है, that's it. Question आ गया, to make ammonium salt. Since all of them are soluble, you're going to use titration. तो इसी के ऊपर हम correction कर लेते हैं. Fill the burette with तो मतलब ऊपर से दो चीजें होंगी. There's going to be a flask at the bottom. There's going to be a burette, just say you'll be pouring stuff, and a flask at the bottom. अच्छा, अब ऊपर से क्या है? There's ammonia falling into it. And नीचे bottom में there's H2. So there's H2SO4 at the bottom. So fill the burette with what? I've filled it with ammonia. So I'm just going to rub this off. And I've filled it with ammonia aqueous. ठीक है, नाम change करना है. अच्छा, pipette 25 cm³ nitric acid. In this case, we have H2SO4. So I'm going to rub that and replace it with, and I'm going to replace it with H2SO4. So add a few drops of indicator. So we'll add that, start titration, and add ammonia in this case, drop by drop. So you'll start adding ammonia aqueous from the top, drop by drop. Stop titration when the color changes, and then you'll crystallize and evaporate the solution. So that's all pretty generic. So otherwise the terminology is going to be exactly the same. Ye clear? So since you have done all of them, I'll just check इसको चेक कर लेते हैं पास with the questions. So कहाँ पे अवेलेबल? ठीक है, preparation of salts के questions है. Now these would include the question length varies from 2 to 4 marks. तो पहला आ गया, वो कह रहा है कैल्शियम क्लोराइड का बताओ कि how would you make calcium chloride? So remember, we'll revise all three methods now. So just a second. So calcium chloride. Can anyone tell me what acid should I use? And it's a soluble salt.
HCl.
Okay, so it's going to be HCl. And we can use a metal base or a carbonate. Let's go with the carbonate. There's some issues with using a metal because I told you कि कहाँ पे हमारी, when we did this, just a second, it's not moving. Oh. So when we were doing this, I told you that with metals, the problem is you can't use any metal because some metals are kind of very unreactive, while other metals are kind of really, really reactive. So sometimes the reaction is very explosive, and sometimes the reaction is going to take years for it to happen. So you can't use calcium metal because I gave you a list of magnesium, aluminum, zinc, iron, and tin. So remember mazit, only use those metals. Baki metals not use karna salt preparation. So if you go back to the question, it's I'm going to use a carbonate, and it's going to produce water plus carbon dioxide. And if I write down the states, balance it as well, this is 2HCl. This one is going to be a solid. ठीक है, if you look at the solubility table, जो के साथ ही है carbonates कहाँ पे लिखा हुआ है, all carbonates, this one, all carbonates and phosphate salts are insoluble. So except group 1 and group 1 salts, this is not a group 1 salt, so it's insoluble. Acids are all aqueous, water is a liquid, and CO2 is a gas. कौन सा method use होगा for making that salt? I mean, is it titration or not? Excess, ठीक है. You can't use titration because titration, you need soluble salt with soluble reactants. That can't happen. If you have an insoluble reactant, that's going to be excess method. और method simple क्या होगा कि add excess, मतलब beaker पकड़ो, you put HCl into it, and you start adding this calcium carbonate, which is chalk. Calcium carbonate, remember, is limestone or chalk or marble. You start adding pieces of calcium carbonate. और इतना ज्यादा calcium carbonate बीच में add करो that all the HCl completely reacts. And all the HCl reacts and turns into salt, water, and carbon dioxide. और वो जो extra excess में calcium carbonate होगा ना, that can be filtered out because it's insoluble, so you can always filter it out. So your solution will only contain the salt without any contaminants or impurities. So this is what you're going to write, add excess calcium carbonate to HCl, and you keep adding until it's in excess. And how do you know it's in excess? When all the HCl completely reacts. When the HCl reacts, the reaction stops. So keep adding calcium carbonate until it remains undissolved or the bubbles, they stop forming and the reaction stops. And your bubbles, they stop forming. So you remove the excess calcium carbonate by filtration. Okay, let me write filter out excess CaCO3. And your solution will only contain this now because this calcium carbonate can be filtered out. So you would have to do crystallization, which is evaporate the remaining solution, evaporate the filtrate to saturation point. So we actually did something terribly wrong in this question. This is not actually the answer, but let me write the whole method that I'm evaporate filtrate to saturation point. You cool gradually and you obtain the crystals and you filter out those crystals. So you filter out the crystals and dry those crystals in sunlight. So what we did wrong over here is that they weren't looking for the method of preparation. उन्होंने सिर्फ कहा था कि there's already aqueous calcium chloride, so you had already formed this. They weren't asking how you're going to form this. They were just asking about crystallization. How would you make pure dry crystals? So the answer to this question was just the last part. You evaporate the solution to saturation point and you cool gradually and filter out crystals and dry those crystals in sunlight. Okay? But we wrote down the entire complete method of preparation. So is this clear? This thing excess method. Is this clear?
Yes, sir.
अच्छा अगला वाला वो कह रहा है कि NOH reacts with iron 2 sulfate, construct the ionic equation with state symbols. And now again over here he's talking about excess method. Describe the essential practical details to prepare pure dry crystals of iron 2 sulfate. So you already told us that add iron powder to sulfuric acid. So Fe plus H2SO4, and it's going to give you what? FeSO4 plus H2. Now the whole thing is, again, it's the same thing. Add excess Fe. You just change the name of the reactants and keep adding into H2SO4, which is aqueous, and keep adding until it remains undissolved. And all the H2SO4 reacts. And the bubbles, they stop forming because all the H2SO4 is gone until it remains undissolved. And the effervescence or bubbles, they stop. And then what you do is remove the excess, filter out the excess Fe. So you're going to filter out the and you crystallize the remaining solution. Like write the whole, you crystallize the filtrate which contains FeSO4. So it's going to be the same details. You've been given 5 lines, so crystallize the filtrate and evaporate the solution till saturation point. So it's again excess method. इधर वो क्या कह रहा है कि you're supposed to make copper chloride from copper carbonate reacting with HCl. So that's obviously going to form copper 2 chloride. So it's going to be CuCl2 plus water plus carbon dioxide. There's going to be 2 HCls. So which method? Cls की क्या solubility है? They're all soluble except for silver and lead. Carbonates, most of them are insoluble except for group 1. Acids are soluble, or water is a liquid and CO2 is a gas. तो बस method बता दो कौन सा method होगा? It's a 3-mark question now. ठीक है, so it's going to be excess again. बस नाम ही चेंज करना है. ये भी excess है. मतलब he's saying कि you're supposed to make zinc nitrate. Zinc is 2 plus from zinc oxide, so that's ZNO. Acid कौन सा use करोगे? That's a base plus acid. What acid would you use? ठीक है, that's going to be nitric acid, and water would be produced. Metal oxide plus acid produces salt plus water, and it's going to be excess again. Nitrates are all soluble. Zinc oxides, that's a solid. So it's going to be excess again. Okay, excess में add करो. Keep adding until all the nitric acid gets used up and it remains, zinc oxide remains undissolved. Filter out the extra zinc oxide, excess zinc oxide, and evaporate the solution till saturation point and cool gradually to obtain crystals. So that's about it. So चलो ठीक है, बाकी फिर एक कोई बीच में टाइट्रेशन का भी होगा कहीं ना कहीं. ये भी excess है. Most of them are excess. So remember, sometimes it's a 2-mark question, sometimes it's a 4-mark question. ये फिर से excess आ गया क्योंकि this is a solid. He gave you the equation already. किधर गया ये? आयनिक प्रेसिपिटेशन का आ गया. चलो ये questions फिर हम कल कंटिन्यू करते हैं, ठीक है? We'll do more of them. Try and revise this thing because you get big questions on this. 3-4 mark questions, ठीक है? If you include the whole question, it's probably going to be a 6-7 mark question, ठीक है? तो ये हम कल कंटिन्यू करते हैं. Okay, take care. Hafiz.